Hello everyone. In this video we're going to be looking at how to do a proper kinematic solution, things you should be looking for, the ways you should be doing the solution so that you don't miss anything and you can get the best possible mark. Here are some of the things we need to look for. Conversions. When using kinematic equations, we have to make sure that we are using base units like seconds for time, meters per second for velocity, meters per second squared for acceleration, and meters for displacement. So if you happen to have something in a unit that's not one of those base units, we have to convert it. And directions, so this is a vector direction, make sure that they are all lining up properly. Make sure that you are adhering to significant digits. And make sure that you are carrying your vector arrows and ensuring that you have vectors as you go through the solution. Here's our first question. Car is traveling at 85 kilometers an hour north when it accelerates to 99.4 kilometers an hour north to pass a vehicle. It takes 2.02 seconds to reach the new velocity. So that's our information. Those are the initial conditions. And now the questions are find the acceleration and the displacement during the acceleration. Now you'll notice that I say step 2, list the variables. Step 1 is read the question. I actually recommend reading it more than once, reading it multiple times to make sure that you actually know what is being asked. Some people actually do things like underline. Here is one of the things I'm looking for. I'm looking for acceleration. Here's the other thing I'm looking for, displacement. Just make sure you understand what it is the question is asking and the information that you've been given. So I'm going to now list my variables. Now, according to the question, the initial velocity was 85 kilometers an hour north. You accelerated to 99.4 kilometers an hour north in a time interval of 2.02 seconds. We're solving for acceleration and we're solving for displacement. So one of the look fors. Do we have vector directions that are the same? And they're both north, so that's fine. Let's take a look at base units. My velocities are in kilometers an hour. Those are not base units, which means we can't actually use them in the kinematic equation. So what we have to do is put them into meters per second. 85 kilometers an hour is equivalent to 23.611 meters per second. 99.4 kilometers an hour is equivalent to 26.611 meters per second. I will not be showing the conversion in this video. I will give you a link on converting from kilometers an hour to meters per second. So we now have meters per second, that's a base unit. This is seconds. We're all good to go. The next step, identify the proper kinematic equation. We have to pick the one kinematic equation that will be used to solve for, and in this case we're going to start with acceleration. So here is the equation we're going to use. Acceleration is equal to v2 minus v1 over the time interval. Next, step 4, sub in the values. Our V2 was 27.611 meters per second north. Our V1 was 23.611 meters per second north. Our time interval was 2.02 seconds. So we've subbed everything in. All of the proper units are there, proper directions are there. So on the top, we end up getting 4.000 meters per second north divided by our time interval of 2.02 seconds. So that actually gives us 1.98 meters per second north. And another way of writing that unit would be meters per second squared. So the acceleration for the car is 1.98, that's 3 sig digs, meters per second squared north. Okay, so part 2 of the question is finding the displacement. We've already read the question over. We're going to list our variables again. V1, V2, time, acceleration and displacement. You'll notice that I did not put the calculated value we just got for A. I would like to pretend that we don't even have that. Because we have 5 kinematic equations, we're able to calculate displacement not using the acceleration value we just got. So let's identify the proper kinematic equation, and we're not going to use the value we just calculated. So don't use that value if you can avoid it. There will be some questions where you need the number that you calculated to solve the second part of the question, but in this case we don't. So this is the equation I'm going to pick. Displacement is v2 plus v1 over t divided by 2. I sub in my numbers. V2 was 27.611 meters per second north. V1 was 23.611 meters per second north. Our time interval was 2.02 seconds divided by 2. In the numerator we get 51.22222 meters per second north times the time interval divided by 2, which gives us 51.734, and the unit will be meters because it was meters per second times seconds. Our question only had 3 sig digs, which means the final answer can only go to 3 sig digs. So our final answer for displacement will be 51.7 meters north. Okay, so recapping the video. A kinematic solution has multiple steps. Step 1, read the question over and understand what the question is asking. Step 2, list your variables, ensuring that you have proper units and directions. Convert where required. Step 3, list the kinematic equation you're going to be using. Step 4, sub in your variables. Step 5, solve, and then make sure that you're checking your final answer for proper units, proper directions, and significant digits.